Well, hello there. Mr. Buck here with a couple of problems from 3.3 and 3.4 from your geometry homework. On the screen here I have problem number 19, and this is from 3.3, where it says an angle's measure is 9 more than twice the measure of a supplement to it. We need to find the measures of the angle and its supplement. So we have to find the measure of two angles here. Two angles. And we don't know the measure of either angle, but we do know the relationship between the two measurements. So we don't know what an angle measure is. One of the angles, we'll just call it x. We don't know what that is. We're going to call it x. And then we know that the other angle's measure is 9 more than twice the measure of that angle. Kind of confusing. So what I have here is an equation. I'll explain what all these pieces are. We have this angle that we don't know, the angle x. And we also know that its supplement, which is what's in parentheses here, is 9 more than twice the measure. So here's the original angle. We're going to multiply by 2, add 9. And when we add these two things together, this word supplement means that the two angles add up to 180 degrees. So here's our first angle, x degrees. Here's our second angle that is 9 more than twice the angle. And now we know that that's equal to 180 because they're supplementary, because we're told that they're supplementary. So now we just have a basic algebra equation to solve, where we have 2x plus 9 plus x equals 180. Combining like terms gives us 3x plus 9. These parentheses can essentially just go away. So the 3x comes from the 2x plus x, which is 3x. The plus 9 is still there, and now we're going to solve for x. Subtract 9 on both sides, and then divide by 3, so we know that one of the angles is 57 degrees. But we want both the angles. It's supplement. A couple ways we can find this here. We know that if the first angle is 57, we can just take that away from 180 to find out what the other measure is. Or we can plug in the 57 right here and do 57 times 2 plus 9. And if we do that, we'll find out that the angles are 57 degrees, because that's what we found out one of the angles was. And its supplement has to be 123 degrees. Number 21, also from 3.3. Suppose an angle measure is x and its supplement is y. We want to graph the set of all possible ordered pairs x and y. So one angle measures x, the other is y, and they're supplementary. So that means if I have an angle x and an angle y, and I add those two angles together, they need to add up to 180. So here's our equation. X plus y equals 180. An angle measure and its supplement, 180. So now we just say, well, what are all the values we can plug in for x and y? X could be 180 and y could be 0. X could be 90 and y could be 90. We can come up with a whole bunch of different values for x and y, and then we want to graph them. First thing I'm going to do is I'm going to put this into slope-intercept form. So what I did here just now is I subtracted x on both sides. And this is in slope-intercept form, but it's not in the y equals mx plus b format, so I'm going to switch them around. So y equals negative 1x plus 180. There's our slope-intercept form. Our y-intercept is 180. Our slope is negative 1. So if I graph that, here's 180. Y-intercept is 180. And then this has a slope of 1, which isn't maybe very obvious there. But all the points on this line, no matter what point I pick, those x and y coordinates will add up to 180. And it goes from 0, 180 down to 180, 0. So this is what that graph looks like, where all these points on this line, if you take their x and y, they will add up to 180. Next one, number 13. This is from 3.4, where the grocery bill for 8 steaks and 2 slabs of ribs came to $65.89. So the 8 steaks must have cost less than $65.89. And we're supposed to name here, I don't have it on the screen, we're supposed to name the property that says, why is this true? How can we conclude that the 8 steaks must have been less than $65.89? Well, we have this property here, some postulates of equality and inequality. This is directly in your textbook here. That says, for any real numbers a, b, and c, whatever you want to call them, a, b, and c can be any numbers you want. And we have this equation to inequality property. And what this says is that if you have two numbers, if a and b are positive numbers, and a plus b is equal to c, then C must be bigger than A, and C must also be bigger than B. And that's exactly what we have here, where we have several real numbers, because we have 8 steaks and 2 slabs of ribs. So the 8 steaks is kind of like the A, the 2 slabs of ribs is the B, and then the C is the $65.89. So you have our steaks and our ribs, and when we add these two things together, they equal C. That means that C must be bigger than A, and C must also be bigger than B. So basically the total cost has to be more than the cost of the ribs, or the steaks, I'm sorry, and the ribs also, and they must also be less than the ribs, and vice versa. So now you're thinking, well, what if the ribs were free? What if the ribs weren't 0? And then in that case, we could say, well, then maybe this isn't necessarily true. But let's just work under the assumption that the steaks cost money and the ribs cost money. They weren't free. If we work under the assumption, then the postulate or the property that says that the 8 steaks must have cost less than $65.89 is the equation to inequality property, which is this right here, saying that if the ribs and the steaks were equal to $65, that means the $65 is more than the cost of the ribs, and the $65 is more than the cost of the steaks. Again, we're assuming that they actually cost money. If it's 0, if you assume that it's 0, then this might not necessarily be true, but let's work under the assumption, which is not very clear in this problem. But if we work under the assumption, then this equation to inequality property describes what's happening here. And our last one, number 17, also from 3-4. We're going to consider this figure at the right where we have a line with 4 points on it, P, Q, R, and S. And let's say that we know that PQ is equal to RS. So this distance right here is the same as this distance right here. They're the same because we know that. We're going to write an argument using the properties of this lesson, properties of equality and equality, and the definition of betweenness to show, again, betweenness means that all these are on the same line, to show that PR is equal to QS. So we want to show that PR is equal to QS. So we want to show that this distance right here is the same thing as this right here. And we know that PQ is the same as RS because we're told that. Now if we take PQ and then we extend it to PR, all we're doing is just adding QR to PQ. If we take RS and extend that to be SQ, then all we're doing really is adding QR to RS. So would PR be the same as QS? And the answer to that is yes, because the addition property of equality says so. Because what we're doing is we have two things that are equal. This is the same as this, and then we're adding to each of those distances the same distance. We're adding the same thing essentially to both sides of this equation, because QR must be the same as RQ because it's the exact same segment. So this PR would be the same as QS because of the addition property of equality. Now part B, it says, what if the equal sign was changed to a less than symbol? What if we said that PQ was less than RS? And then write an argument using the properties of this lesson and the definition of betweenness to show that PR is less than QS. So now we're working under the assumption that this distance right here is less than this distance right here. How would this change the problem in part A to show that PR is less than QS? It would be exactly the same thing. The only difference is we would use the addition property of inequality to conclude that PR was less than QS. Because now, if this is less than this distance right here, if PQ is less than RS, and then we add the same distance to each of those segments, this distance will still be less. The distance of PR would still be less than the distance of SQ. It's kind of like you say that 3 is less than 4, and then if you add 8 to 3 and 4, what was the 3 will still be less than what was the 4. And that's exactly what's happening in part B if we change that to a less than symbol.